We're going to do a little bit more work with probability today, specifically the probability multiplication rule. So we've been dealing a lot with sample spaces, which are a list of possible outcomes. Probability multiplication rule kind of allows us to skip that list a little bit here. Let me give you the definition here of the probability multiplication rule anyway. Basically, it says that if the probability of one event occurring is, let's say, n, and the probability of another event occurring is, let's say, m, then the probability of A and B occurring together is equal to n times m. So if you want to know the probability of both things happening, you multiply their individual probabilities by each other and you'll get that probability. So let's go ahead and try this here. In a certain experiment, a coin is tossed and the spinner is spun. Compute the probability of the events in A and B here. So they want to know the probability that when we flip a coin and spin the spinner that we get heads and blue. So we're going to do the probability of heads times the probability of blue. Now, the probability of flipping heads on a coin we know is 1/2. Okay, 1 out of every 2 times. There's 2 possibilities, heads or tails. One of those possibilities is heads. And the probability that we spin blue on this spinner is 1 out of 3. So there are 3 possible things that can happen. They're all equally likely, white, blue, and gray. And only one of those is blue. So the probability that we get heads and blue would be 1/2 times 1/3, which is 1/6. So 1 out of every 6 times. Now if we made a sample space, that sample space would be heads white, tails white, heads blue, tails blue, heads gray, tails gray. And 1 out of those 6 would be heads and blue. Now, the next one here says the probability of heads and not blue. So we would do the probability of heads times the probability of not blue. We know the probability of heads is 1/2, and the probability of not blue would be 2 out of 3. So the probability of heads and not blue would be 1/2 times 2/3, which is 2/6, which is 1/3. So just a little bit more here. I want to show you this sample space here. We can get heads or tails on a coin, and then we can get white, blue, or gray on the spinner. So here's my sample space. Heads with white, heads with blue, heads with gray, tails with white, tails with blue, and tails with gray. So if we want to do the probability of heads and blue, there's the only 1 out of the 6 that is heads and blue. And if we want to do the probability of heads and not blue, there are the 2 that are heads and not blue, 2 out of 6, which we already said simplifies to 1 out of 3. So that would be a method of doing sample space, but this probability multiplication rule kind of speeds things up. Next, 2 number cubes are rolled. What is the probability of rolling a number greater than 4 on each number cube? Okay, well, on the first number cube, we could do the probability of getting a number greater than 4. I'm sorry. The probability of getting a number greater than 4 on both would be equal to the probability of getting a number greater than 4 on the first times the probability of getting a number greater than 4 on the second die. Okay, so the probability of getting a number greater than 4 on the first would be 2 out of 6. 5 and 6 are the only numbers greater than 4. And the probability of getting a number greater than 4 on the second die is also 2 out of 6. 5 and 6 are the only numbers greater than 4 on a die. So we'll just multiply those together, and we'll see that it is 4 out of 36. which is a 1 out of 9 chance that you get a number greater than 4 on both die. Now, let's break that down a little bit more too. Here's the sample space for what you can get when you roll 2 die. You can get a 1-1, a 1-2, a 1-3, a 1-4, a 1-5, a 1-6, a 2-1, a 2-2, a 2-3, a 2-4, a 2-5, a 2-6. Here are all the possibilities when you roll 2 die. So 1 on the first die, 2 on the first die, 3 on the first die, 4 on the first die, 5 on the first die, and then 6 on the first die. There's all the possibilities. Now, how many of those possibilities have greater than 4 on both die? 1, 2, 3, and 4. And there are 36 possible outcomes here. Now, the probability rule of multiplication rule of probability is a lot faster than writing out the entire sample space and then finding out which events meet this criteria. Okay, last one. A coin will be flipped 4 times. What's the probability the coin will land heads up all 4 times? Well, there's the probability that we get heads once, and then again, and then again, and then a 4th time. So that would be 1/16. So if it's the same probability every single time, then we could just do 1/2 to the 4th power, which is 1/16. All right, that's all I got for you today. Pretty basic concept here. Watch the video again if need be, and I'll see you tomorrow. We can give this a shot.